Friends, so in the we have just discussed about the introduction to the material engineering and what are the outcomes after the completion of this course. So today we will start with the introduction part about the material engineering. So in the introduction part we will talk about the relationship between materials and the civilization, the relation between material and engineering, and what are the structure, the effect of materials on the properties and on their performance, and the different types of materials. So let's start with the materials and the relationship between civilization. If we talk from the historical perspective, so materials were introduced with the start of Stone Age. So beginning of material science, people began to make tools from stone. The Stone Age started about 2 million years ago. At that time, the natural material was stone, wood, clay, skin, etc. The Stone Age ended up about 5,000 years ago with the introduction to bronze in the Far East. Bronze is an alloy, a metal made of more than one element. The base metal was copper and tin and some other elements. Bronze can be hammered or cast into a variety of shapes, can be made harder by allowing corrode only slowly after a surface oxide film forms. The Iron Age began about 3000 years ago and continues today. So after the end of Stone Age, Iron Age started. The use of iron and steel, a stronger and cheaper material, changed the drastic daily life of common person. So in continuation to Iron Age, the advanced materials are also introduced. Throughout the Iron Age, many new materials have been introduced like ceramic, semiconductors, polymers, composites. So the understanding of the relationship among structures, properties, processing and performance of materials, the intelligent design of a new materials. Understanding the structure, composition, properties lead to a remarkable progress in the properties of materials, like in the strength, density ratio of materials, resulted in a variety of new products from dental materials to tennis rackets. So from this diagram you can see that, so with the passage of years, how the strength to density ratio of materials changes drastically. So what is material science and engineering? Material science is the investigation of the relationship among processing, structure, properties and the performance of the materials. So materials are integral part of human culture. So in the past, stone, bronze and iron ages. So what is the role of engineer? Adapting materials and energy to society's needs. The properties of material depends on internal structure. To change the performance of materials, modification of internal structure is required. Humans are able to make things like objects, tools, component systems. This requires materials to meet these purposes. These days are not limited to one prominent materials. A lot of sophisticated materials like plastic, silicon, titanium, high technology ceramics, optical fibers and so on. So that's, we can say that it's the age of a technology. Engineers design products and systems and monitor their uses. Every product is made of material and energies involved in the production and in the use of that. This is why all engineers have to study material science during their undergraduate study.
Materials. Materials are all around us. We use them in our everyday life. But what are the most common materials? What do they make? And what properties do they hold? These are the key insights that we will try to uncover in this module. For engineering purposes, materials can be divided into 4 key areas. The first is metals. Metals are the widest used of the 4 materials. Even if a material is not made of metal, metal will have been used at some point during its manufacture. Metals are used for everyday objects like cars, buildings, and bridges, but also go into extreme applications like jet engines, mining equipment, and space exploration. Even the tallest buildings in the world are only possible due to metals. The second material is polymers, which includes plastics. Polymers are widely used in many different industries. Natural polymers consist of amber, wool, silk, natural rubber, and cellulose, which is the main constituent of wood and paper. These natural polymers have been used for centuries. More recently, synthetic polymers have been produced, and these have revolutionized modern society. These include synthetic rubber, nylon, PVC, polystyrene, silicon, and many more. The third is ceramics. Ceramics have been used for thousands of years, and the most common two are glass and clay. Clay was the first material that we learned to transform into another state using fire. This was done about 29,000 years ago, when clay was formed into decorative figures. Much later, clay was used to form items like jugs and bowls. Glass, which is mainly made from sand, was mastered by the Romans, who unlocked the secret of blown glass by mixing it with minerals. The Romans were the first people to use glass for windows. The fourth material is composites. A composite is a combination of 2 or more materials. Composites have been used for centuries in the form of concrete. Again, it was the Romans who really mastered the process. In text from 25 BC, different aggregates are discussed for use in lime mortars. In 1853, steel bars were first added to concrete, making it one of the widest used composites, reinforced concrete. Metals can be divided into 2 subgroups, ferrous and non-ferrous. In ferrous metals, the main constituent is iron, and this group consists of steels and cast irons. For the amount of strength that is achievable in steel and cast irons, it is a cheap material. This is because iron is one of the most plentiful elements in the Earth's crust. Non-ferrous metals include any other metals. Some examples are aluminium, copper, zinc, titanium, and nickel. Metals have good electrical and thermal conductive properties. They are ductile, strong, tough, and have strength at temperature. Polymers are organic carbon-containing molecular chains. They have a wonderful array of properties and are primarily made up from hydrocarbons. These are the building blocks of plastic. Hydrocarbons are a byproduct from petroleum industry, and due to this, they are abundant and therefore a cheap material. The carbon and hydrogen which make up the plastics are the key to how they work, because they can form together to produce long chains. This enables plastics to be versatile and easily processed. How the material is processed can produce the desired combination of properties. The strength can be varied, the toughness can be varied, they can be a good conductor of electricity and are often very good insulators. Again, ceramics can have a wide array of properties, and in recent years we have really begun to understand them. Semiconductors have been produced which, when cooled, have virtually 100% efficiency in electrical conductivity.